Okay, so that for this first question, when they're talking about this single phase motor takes 8.3 amps. So this would really be your circuit diagram for this single phase AC motor load. So you've got your RL load and that's your motor. And that is taking 8.3 amps. And the power factor of that RL load is 0.866. From that power factor, you can get the phase angle by doing the inverse cos of that. So if you do that, that gets you an angle of 30 degrees. So now you know the current is 8.3 amps, the angle is 30 degrees. The voltage for the supply is given to you in the question. So from this, you should then be able to go on and do your phasor diagram for that. So when you've got the current through your RL branch and you've got the angle, you should go back and look at your basic phasor structure if you like. You know your IRL is going to be in this quadrant and your angle gives you the angle from that reference axis there, the angle where your VS would be. So if you draw out your phasor shape like this, you should be able to fit in your IRL being 8.3 and the angle of that should be 30 degrees. That's what you're trying to do. So if you've got a protractor and a ruler, that's obviously what you need. 30 degrees is 30 degrees from the reference axis, which is this axis going out to the right positively. It is just a sketch, so it doesn't have to be exact, but the better it is, the easier it is for you to work things out. Go a centimetre equals 2 amps for me. That's my IRL, and that's my 30 degrees. Now what they're asking you to do is to work out what value of capacitor you could connect in here that would improve the power factor from 0.866 to unity, unity being 1. So you want to correct the power factor to 1. To correct the power factor to 1, you have to have your VS and your overall IS in phase. So your VS, that's that 230. I'll mark that in here as well. Now your IC usually goes on this axis vertically. That's where that IC would be. To determine the right value of IC, you're going to look at how much on that axis you would need to get this distance here. So you're looking at getting this much by adding an IC here. Yeah? So you're working out which value of IC you can put on the end of that IRL that will give you an IS that's in phase with your VS, which then means you've got a phase angle of 0 and a power factor of 1. So you want your IS to be in here. The phasor addition of IRL and IC. So your next stage from this is to use this right angle triangle to work out the size of IC And then from IC, you should be able to work out your XC and your value of C from that. So to get your value of IC, when you're looking at this, it's a right angle triangle, isn't it? So there's your angle, that's your opposite, and that's your hypotenuse. So you would use sine of the angle is the opposite over the hypotenuse from your SOHCAHTOA. So sine of 30 is the opposite, the thing you're looking for, IC, over your IRL, which you already know, you had that from a way back there, 8.3. So it'll be 8.3 times the sine of 30. Gets you 4.15. And that should kind of tie in with your scale. So my scale, a centimetre equals 2 amps. I'm measuring just over 2 centimetres, so that's just over 4 amps. That's fine. So that's me. I've got my value for IC. Now I want to actually get my capacitor value from this. So to get my capacitor value, I need to know what my XC is, and then get my C from that. So I know that Z equals V over I. And I know that for this branch, the only impedance that's in it is the XC. So I can go from that to XC equals V over IC. So my V, 230, my IC, 4.15. Just using the magnitudes. 230 divided by 4.15. So that gets me 55.42. XC is measured in ohms. And then from that, I know that XC equals 1 over 2 pi FC, and I can transpose that to make C the subject. Give me this formula. So it becomes 2 pi times 50 times our 55.42 that we just worked out over there. That's where that's come from there. So when I engineer my answer, I get 57.44 times 10 to the minus 6. Capacitance is in farads. So that's 57.44 microfarads. And that would be that done.